Today, we're gonna study about mechanics. There is a note of question for those with a physics phobia because this lecture contains some basic physics applications, but I gonna try to explain them sufficiently so it could make sense and will be applied only when necessary. So don't worry, let's start. As you have studied earlier that kinesiology brings together the fields of anatomy, physiology, physics and geometry and relates them to the human movement. Thus, kinesiology utilizes the principles of mechanics, musculoskeletal anatomy and neuromuscular physiology. So before you start studying mechanical principles, at least you should know what is mechanics. Mechanics is the science of the movement of material bodies. Mechanical principles or the principles of movement depend on the causes that cause movement. These are mainly the forces that emerge as the application of laws of movement in nature, created by the purpose that occur in matter due to, again, natural laws and phenomena. These principles relate directly to the human body and are used in the study of biomechanics. Because we may use a ball, racket, crutch, prosthesis or some other implement, we must consider our biomechanical interaction with them as well. What is force? A push or a pull is called a force. It is a vector quantity which alters the state of rest of a body or its uniform motion in a straight line. Force may also cause means start or prevent, that is stop or modify motion. It could either accelerate or decelerate or change the shape of an object. A force has both magnitude and direction, making it a vector quantity. For example, if you were to push a wheelchair, you will move it in a certain direction with certain speed. As we all know that force is a vector quantity, so it is represented by an arrow sign. It is a product of mass and acceleration and having a unit Newton. There are four components of forces. Number one is magnitude, which is proportional to the length of arrow. Number two is direction, which is denoted by arrowhead sign. Number three is angle, which is also known as action line or angle of pull, which is indicated by the angle of the arrow with the horizontal line. Number 4 point is the point of application, which is indicated by the tail of arrow. There are various types of forces, but in this video, we're going to learn about the forces which are acting upon a human body. There are two types of forces which are acting upon a body. Number one is internal force, which is acting from inside the body. Second force is external force, which is an outside force that is acting upon the body. Moreover, the forces which are acting internally includes muscle force, which is produced by muscle contraction. Ligament force produced by ligament pull when the ligament is stretched. And a joint reaction force which exists between the articular surfaces of a joint. Perhaps the forces acting upon a body externally includes gravitational force, ground reaction force, friction, pressure, and resistance. Let me tell what they actually are. Gravitational force is a force which tends to pull the body downwards. Ground reaction force is a force which is exerted on the body by the ground. Friction is a force which exists between contact surfaces. Pressure, it is exerted over the area of contact between two bodies. Resistance is a force like friction which tends to oppose the direction of a motion of a body and tends to prevent or slow down the body's motion. Newton's first law of motion is also known as law of inertia, which stated that with no net force acting upon it, an object at rest tends to stay at rest, and object in motion tends to stay in motion. Both objects will continue with same inertia and keeping the same velocity. For example, the ball will not move unless there is an external force that applied over the ball to cause it to move. If a ball were rolling on a frictionless surface, it would keep moving unless an outside force acting upon it. So that force action is known as inertia. Newton's second law is also known as the law of force, and it states that the acceleration of an object is dependent upon the net force acting upon the object and the mass of object. Okay, now question is, why is this so? Answer is because the mass of each ball is different. Each ball will travel a different distance at a different speed when it is hit with same force. Coming up to the Newton's third law, which is also known as law of action and reaction, which states that for every action there is an equal and opposite reaction. For example, if you hit the ball on the wall, and it will bounce back with the same or equal force but in opposite direction.